Hello everyone and welcome to a physics session with me. Um, this is a very interesting chapter in your syllabus. It is the chapter on current and electricity. It's going to come in parts. I'm recording it in parts so it makes it more interesting for you and sustains your interest and you enjoy the teaching. You know, the first slide is just to introduce the topic, the chapter. It's current and electricity. Very, very exciting, very interesting chapter in physics. So let's get started together. Hello. So the first thing to know in current and electricity is how does this whole thing work? What is it based upon? I'm sure you have studied in 7th and 8th standard about a cell. They teach you the basics and they just work on it every year. You must first know what is a cell. Unless you know what a cell is, you will not know what an electric circuit is, how it contributes to the electric circuit, how does an electric circuit work. So it's very important to first understand what is a cell. A cell. So let's work on this together. I have made out the definitions into boxes with pictures to make you understand, make it easy. If they ask you the definition of a cell, what is a cell? All these points are valid there. A cell is a source of direct current which lights up a bulb. So if you look at this picture, you have a cell. It is a source of current, and when the circuit is complete, when the switch is here on, the bulb lights up. So the current flows into the circuit and the bulb lights up. So a cell is a source of direct current. Current is directly flowing into this circuit through this cell. A cell is a source of direct current called DC, which lights up a bulb. Now it is important to know this. Current flows from the positive terminal of the cell to its negative terminal through the bulb. Here it is marked positive terminal, here it is marked negative terminal, and here is the bulb. So it is going to travel from the positive terminal. Look at the arrows. The switch is on from the positive to the negative, into the circuit, into the bulb, lights it up, out from here. The circuit is complete, it travels this way and comes back into the positive terminal. So this positive terminal is where the positive electrode is. The negative terminal is where the negative electrode of the cell is. And this is a dry cell. In a cell, the third point, chemical energy changes into electrical energy when it sends current in a circuit. What is stored in this cell? Chemicals, chemical energy. And when you complete the circuit, this chemical energy stored inside the cell is converted to electrical energy that lights up this bulb. So understand this part of the cell also. The magnitude is this word magnitude comes a lot in physics. What does it mean? The strength. The value, the magnitude is a strength value of current given by a cell remains constant for a long time. When the cell gets discharged, it stops giving current and becomes useless. So it's important to know these 5 points about a cell. If you look at the cell, what are the parts of a cell? The positive and the negative parts of a cell. A dry cell comprises the following parts. First is a vessel. This is the vessel containing two conducting rods called the electrodes. So you have these two, look at this rod. This is the conducting rod, or these two rods here. They are called the electrodes. Here it is a zinc container. It's given a zinc container. Okay. Now, the electrodes are placed at some separation, immersed in a solution or jelly called electrolyte. So you have these electrodes here. They are immersed in a jelly. If you look at this one here, this red thing is the electrolyte. So there's one electrode here and there's one behind it here with some separation. And they are inside is behind this second electrode in an electrolyte, a jelly-like substance. The brass cap projecting out at the center acts as the positive terminal of the cell. The metal is a metal cap. It is a metal cap or a brass cap. It is a metallic cap. Here it's here. Okay. The base is a zinc case. This part is a zinc case. See, it says here paste of NH4Cl and ZnCl2. It's a zinc case that acts as the negative terminal. So this is the negative terminal. This is the positive terminal. There are two electrodes immersed inside an electrolyte solution in some distance. The electrodes are at a distance. They're not stuck together. There's a distance between them. Okay. So the basic setup of a cell you must understand. You must understand first what are the properties of a cell, and then what are the contents of a cell. So a cell consists of two conducting rods. They have to conduct electricity, right? They can't be non-conductors. Conducting rods called electrodes. Electrolyte, a jelly-like solution. A brass cap on top, that is the positive terminal. A zinc base, a case of zinc, that is the negative terminal. So just remember this. Look closely at these pictures. Try to understand what the text is telling you. Learn these points up. They are the answers for your exam. What are the positive and negative parts of a cell? Here you are. What is a cell? Try to remember as many points as you can from here and write it. That's a cell. It's a source of direct current which lights up a bulb. And all these properties, and what are these positive and negative parts of a cell. Alright? Hello. So the next thing you need to know, you've understood what is a cell, what are its contents, what is it composed of, what is it composed of, what are its properties. Now, there are two kinds of cells, primary cells and secondary cells. Secondary cells are also called accumulator cells. Okay, I have put the pictures of all the four primary cells here. What is a primary cell? A primary cell provides current as a result of an irreversible chemical reaction. The chemical reaction happening in a primary cell cannot be reversed. So, primary cells cannot be recharged. One-way traffic. Charge them, they lose charge, throw them. That's it. They're done and dusted. So, they are a consequence of, the current through them is a consequence of an irreversible reaction. Chemical reaction, mind that. In it, chemical energy is converted to electrical energy. Chemical to electrical when current is drawn from them. When current is passed through them, it means current is drawn through them. So if you look at this circuit here, current is drawn from it. Current flows from the positive to the negative, out of the negative, around here into the bulb and back into the positive. So energy is drawn from it. Electrical energy. It cannot be recharged. Its internal resistance is high. It is because of the internal resistance being high, it is capable of giving weak current only. The current that you pass through it is weak. It is light, it's not heavy, and it's cheap. So the first example is a dry cell, this one. The easiest form to understand of a cell is a dry cell. Then you have the other kinds of cells, the Leclanche cell, the simple voltaic cell, and the Daniell cell. These are the four types of primary cells. So what are primary cells? Cells that provide current as a result of an irreversible chemical reaction. It's an irreversible chemical reaction. Okay, they cannot be recharged and they give only weak current. And chemical energy is converted into electrical energy when current is drawn from them. All right. So then what is a secondary cell? It's also called an accumulator. What is a secondary cell? A secondary cell provides current as a result of a reversible reaction. The reaction going on inside this, it's a big thing actually. Look at these three pictures here. These are the secondary cells. This is an NiFe alkali accumulator. This is an LiH battery, and this is a lead or acid accumulator. So here there is a reversible reaction going on inside them. Chemical to electrical, electrical to chemical. So the reversible reaction going on. So they can be recharged after use. During charging, when current is passed in it or through it, electrical energy converts to chemical energy. To charge it, you plug it in. So electrical energy converts into chemical energy. During discharging, when current is drawn from it, now you put it in a circuit, put a bulb, put whatever you want with it. When current is drawn from it, then chemical energy converts into electrical energy. So it's reversible. You can charge it. By charging it, current is passed in it and your electrical energy converts to chemical energy. When you use it in a circuit, then the current passes through it, the current is discharged through it. You use its current, like in a car maybe, you use its current and it gets discharged. When it is getting discharged, chemical energy becomes back to electrical energy. So it can be recharged. Its internal resistance is low, and so it can provide low as well as high current. So very user friendly. It is heavy and costly. There is the catch. Would you put a big battery like this with your remotes at home and stuff? No, they have those small dry cells, right? Depending on the utility of the cell, you want to use that. The examples are the lead or acid accumulator, here it is, the NiFe or alkali accumulator, which is here, nickel ion, and lithium LiH battery, which is here. So this is an easy one. A secondary cell can be recharged. Electricity, it's the reactions inside it are a result of the reversible reactions, the current that comes or goes out of it. During charging, current is passed through it, electrical converted to chemical. During usage, current is discharged from it, chemical becomes electrical. Understand the concepts clearly, then you never falter on the, which cell is being used where, what, why, difference between. You will not falter. Okay, this is very easy. Read these points carefully. Just learn up these points. Just learn them up. What is secondary cell? Here you are. What's a primary cell? Here you are. Examples? Here you are. I understand everything. Good. This may look repetitive, but I like doing question answers. I like to understand, my children should understand how to apply what they're learning through my slides into question and answers. What's the point otherwise? Learn to apply what you've learned. And I do these question answers so that you understand how to write answers. Once you get to the rut of it, once you understand what's happening, you'll do it on your own. So let's go for it. What is an electrical cell? Electric cell. Same points. An electric cell is a source of direct current, DC, which lights up a bulb. Current flows from the positive terminal of the cell to its negative terminal through a bulb. In a cell, chemical energy changes into electrical energy when it sends current in a circuit. When the current is in the circuit, the chemical energy of the cell is converted to electrical energy and the bulb lights up. The magnitude of current given by a cell remains constant for a long time. Not first second high, second low, no. It stays constant for a long time. Then it gets discharged, then it wanes away. When the cell gets discharged, it stops giving current and becomes useless. Right? This is a dry cell, this is a primary cell. Name the constituents of a cell. Constituents means kya hai uske andar? What does it comprise? These are all words in English. Constituent means what is inside it. It contains 2 electrodes and an electrolyte in a vessel. A chemical jelly kind of liquid. Okay. What transformation of energy takes place when current is drawn from a cell? A cell has chemicals in it, the electrode and the electrolyte in it, 2 electrodes and electrolyte in it. Now, when current is drawn, circuit is complete, the cell has to give energy. Then chemical energy is converted into electrical energy. Remember, current drawn means cell discharged. When the cell is charged, you're plugging it in. Electricity becomes chemical. This is asking you what transformation of energy takes place when current is drawn from a cell, taking it out in a circuit. Then it is chemical energy getting converted to electrical energy. Remember that. See these things, these fundas, these basics, you understand and remember well, anything in the chapter you can do. State 2 kinds of cells. Give an example of each. You all know it by now. Primary cells, example dry cell. Secondary cells, LiH battery. Name one AC and one DC source. Now know this. Direct current source is the cell we're talking about. It's direct. The cell gives alternating current, AC. Our mains in our house, they are AC. So you should understand. This concept will come ahead now. I'll explain the terms to you. I'll give you examples. I'll give you a difference between. But understand. AC source is the mains in our house. DC source is the cell. Remember this, okay? So learn these questions. This is how I would test my children if I wanted to ask in a chapter. So this is the way to do it. And then these are questions from the textbook and last exam papers and stuff. Okay. These concepts come in the later half of your chapter, but they are also dealt with in the beginning. So I want to just introduce them to you so you understand what's happening. You have alternating current and you have direct current. I always start with direct current. One that is through a dry cell. Electrons Electric current is the movement of electrons. You all know that by now. Okay, even if you don't, in an electric circuit, how is electricity passing? It's the movement of electrons. They get charged, right? So now electrons move only in one direction, that is forward in direct current. Electrons in alternating current keep changing direction. Oh, I'm going this way, oh, I'm going backward, oh, I'm going forward, oh, I'm going backward. They can change their direction. That's the benefit of alternating current. Direct current cannot travel for a very long distance. It loses electric power. What are the sources? A chota battery or that big battery, secondary cell, right? Now, can you keep a secondary cell in my house here and light up the neighbor's house? You can't. It can't go for, maybe you can here, but I can't light up the next building. They cannot travel for a long distance. Alternating current is safe to transfer longer distance even between two cities and maintain electric power. Steady magnetism makes direct current flow in a single direction. Rotating magnets cause the change in direction of electric flow in alternating current. Direct current has no frequency or zero frequency. Frequency of alternating current is dependent upon the country, but generally the frequency is 50 Hz or 60 Hz. Direct current flows in a single steady direction. It just is steady in one direction. AC can flow backward or forward. The AC flow of current, in AC the flow of current changes its direction backwards and forwards periodically. Just remember these points, they'll be handy as the chapter goes by. All right. This is the important slide for what we have studied up to now. Up till now, primary cell and secondary cells, the difference between them. Very important. If I was setting a paper, I would ask this question. Write 2 differences, 3 differences, or based on chargeability, internal resistance, strength of current, cost, chemical reactions, which energy converts to which energy. Very easy. First point. Chemical reaction is irreversible in a primary cell. Chemical reaction is reversible in a secondary cell. Chemical energy gets converted into electrical energy when current is drawn from a primary cell. Electrical energy is converted into chemical energy when current is passed through a cell during charging, a secondary cell. And chemical energy is converted to electrical energy when the current is drawn from it, put into a circuit during discharging. A primary cell cannot be recharged. Because why? Because the chemical reaction inside it is irreversible. A secondary cell can be recharged. Why? Because the chemical reaction inside it is reversible. Its internal resistance is high for a primary cell. Secondary cell internal resistance is low. Primary cell is capable of giving weak current only. Secondary cells can provide low as well as high currents. A primary cell is light and cheap. A secondary cell is heavy and costly. Give an example of each. A primary cell, dry cell, Daniell cell, and a secondary cell, lead or acid accumulator. Once you have understood each cell correctly, its properties correctly, there is no way you are not going to be able to compare the 2 kinds of cells. And if anybody asks you the definition of either, learn this table up. If you are asked definition of primary cell, write points 1 to 7 here. Secondary cell 1 to 7 here. So you don't even have to learn the previous slides. Just learn this one slide. You'll know the examples of both. You'll know the definitions of both. Difference between both. Make life easy. Yep. So like I said, I like to convert the theory into questions. You have to learn how to answer questions, to apply what you've learned. That's important. So if you look at this slide, I just put questions here for you for the stuff that we have learned till now, primary and secondary cells. All right. Why is a secondary cell preferred over a primary cell? A secondary cell is preferred over a primary cell because in secondary cells, the chemical reaction is reversible and so they can be recharged after use. They can also be used for a very long time as can be recharged again and again. A dry cell, once discharged, has to be thrown. Correct? Okay. Next one. Which cell is used as battery in a car? Come on. All of you must be knowing this. Lead accumulator cell. Why are lead accumulator cells used as a battery in a car? Because it's capable of giving high current. Which cells are commonly used in toys and mobile phones? All of you need to know. Low current rechargeable cells, not non-rechargeable cells. Then you have to throw your phone. Rechargeable cells, low current. If you pass high current, the battery burns. You know that. The circuit gets burnt inside the mobile phone. What are secondary cells or accumulators also called? Accumulating what? Energy. So they're called storage cells. Explain the working of a secondary cell. It's beautiful. I love the secondary cells. In a secondary cell, after taking the electrodes and electrolytes in a vessel, the cell is first charged by connecting it to a direct current source. Only when a cell is charged can it give current in a circuit, right? We can discharge the current from it, okay? So it is first charged by connecting it to a direct current source. When it is getting charged, during its charging, electrical energy is converted to chemical energy which gets stored in that cell, okay? Then when the cell is used to send current in a circuit, now the cell is fixed into a circuit, the wiring is done, the switch is put, the bulb is put, and the switch is turned on. When the cell is used to send current in a circuit, chemical energy stores in it gets converted to electrical energy. This is important to understand. When you're charging the cell, electrical becomes chemical. When you put the cell in a circuit and switch the circuit on and start the light bulb to glow, chemical has gone to become electrical energy. Since they can be recharged again and again, these cells can be used for a very long time. Name two types of cells, secondary cells, commonly used to provide low as well as high current. Just learn these up. Lead or acid accumulators, NiFe or alkali accumulators. This is the way you must prepare questions for the exam based on, or just for yourself, for your understanding of the subject, for your understanding of the basics of electricity and current. Questions should be understood clearly and answered. Then you know your concepts are clear. That's why I say learn the basics. You learn the basics, you can tackle anything. If you haven't understood the basics, it just gets worse over time. So learn the basics. Learn the basics made easy with UJC. You're enjoying my videos. You would like to have the next part. There's a number here. You can just message me here. You can WhatsApp me here and tell me that Auntie we'd like to have, or Usha ma'am, we'd like to have the next part of this physics. If you would like to look at it, and I'll send it to you. I made them in little parts so that you know the mind of yours assimilates it in small bits. So when you finish a part with me, go back to the first slide, just do a recap once without even listening to what I have to say. Just look at the slides and just recap it, and then go to the next one. So if you would like me to share the following parts of this, just message me on this number with your name, and I'll be happy to know that you are enjoying the videos and you'd like to see the next one and learn more with me or enjoy learning the basics with me. Thanks for being there with me. Take care. Bye bye. God bless.